Try our hearts to God, confess that we not only do what we do, His sustaining our lives and our activities, our ability, and the entire world. Father, we do praise you. We extract kingdom power and glory to you. We are grateful for your wonderful plan that you've made the world good, and that you allow us to explore it and to participate in the kingdom advancement of the kingdom of your Son. In His name we pray. Amen. Plan for today. Going to start with questions on pre-class work. Reminder from the syllabus, little lecture, an activity on exponential functions. That is section that we're doing today. It is section on exponential functions 4.1. I guess he turned it off. Break, continue the activity, homework lab, questions and check for understanding, and a debrief. So questions on pre-class work. Problem. I know one question that I saw that was good. Let's see. Was Jace's question. So I want to be sure to get to that. Now, there were a few questions that the person said, I didn't understand how to do number 3, or I didn't understand how to do number 4. And that's not really a good my question. In each case, I replied to supply a screenshot or just something, that we can go on, so that I or someone else who wanted to reply wouldn't have to go back and look up what the problem was to try to help, the questioner. So anyway, please supply a screenshot or something there on those kinds of questions. Of course, these questions are supposed to be on the media. But let's look at Jace's question, even though he's not here. It's a very good question. Very, very, it goes directly to what we're doing here with exponential functions. And I know it's here somewhere. There he is. How do I tell if a table is exponential or linear? And the thing on this is it's very basic, but it's like, yeah, you're looking at a table and you don't really know what you're looking at. And it's pretty straightforward. And if you think of it this way, you'll know what you're looking at and you'll know how to tell if what you're looking at is exponential, linear, or neither. That's a common problem that we have. Let's see. I just saw this right before I came in. So this question about linear, exponential, or neither is really the question. Um, Linear is, to oversimplify, add the same thing every time. Add the same thing every time. And exponential is multiply by the same thing every time. Okay. Any other question on the pre-class work? I replied to a few of them in my questions, but you might have come up with some other questions that don't have to do with the videos or have to do with exponential functions. Okay, so objectives: evaluate exponential functions, find the equation of an exponential function, use compound interest formulas, evaluate exponents with base e. Here's a definition of exponential function. B to the x, okay? So you're like, well, I mean, we've had exponents before. Aren't those exponential functions? Well, that's not exponential. That's a squaring function. This is a polynomial function. But polynomial functions, even though they have exponents, are not what we consider exponential. These are examples of exponential functions. 2 to the x. What's the difference between the two? Yes, exactly. Now the variable is in the exponent. Before, the variable was in the base. So that's the whole difference there between exponential and, say, a power function like x squared or polynomial function. So graph the function f of x equals e to the x plus 1. Now, I want to pause, and first talk about that number e, that base there. That is a constant. In some ways, it's like the constant pi. The number is irrational. And, it's like, how do we get that number? Now, what I want to do is pause the pause, and talk about the man who discovered the significance of this number. And that is the great Houston mathematician, Euler. And I'm reading from the book Mathematics Is God Silent by James Nichol. Leonhard Euler, 1707 to 1783, was a key figure in mathematics during his lifetime. Born in Switzerland and the son of Calvinist pastor, he further exemplified and illustrates some of the remarkable work accomplished by mathematicians of his time. His mathematical productivity was truly incredible. He wrote a score of textbooks. What's a score? 20. store of textbooks covering many mathematical topics. What was that, Sterling?
I didn't know that there was actually a number assigned to that.
Oh, yeah. Store. Most of them became standard works for over 100 years, and even today, many university textbooks follow Euler's method and order. His Introductio in Analysis Infinitorum, first published in 1748, was considered by mathematics historians to be one of the most influential textbooks in history. In this text and others like it, we see Euler employing a new configuration of mathematical thinking. Before Euler's, that's Euler, by the way. Euler. It's I don't know, the name looks German, but it's Swiss. Anyway, before Euler's innovative style appeared in mathematics, one meets with great difficulties in the attempt to understand the writings of his predecessors. Euler was first to devise the ingenious teaching art of skillfully letting mathematical formulae speak for themselves. So, learn by doing. And Euler, I mean, not only was he a great, mathematician, but also a great educator. So in elementary mathematics, we owe to Euler the conventionalization of the following notation. So these are things that we see all the time. Notations in mathematics like f of x, that seems to Euler. The base of the natural logarithm, number e, that came from Euler. We're going to talk about, how that number is derived. See up there. Sides of the triangle ABC, the semi-perimeter. Now, I thought that was like using Heron's formula, but I guess it's just a notation, S for semi-perimeter. The summation sign, capital sigma. Okay, what does that look like, capital sigma? It looks like an E, right? In fact, if you, I think Caesar's Palace does this. My mom used to live in Vegas. They use like that for an E, but it's really an S. And it's used in summation notation. If you haven't seen it used that way, you will. The imaginary unit I, Euler gave us the letter I for the imaginary unit. In addition to textbook writing, he wrote highly original research papers at a rate of about 800 pages a year during most of his lifetime. The last 17 years of his life were spent in blindness due to cataracts, but he did not stop his productivity. Sustained by his faith, he dictated his research and findings. His powers of concentration also enabled him to do this because he was able to perform complex mathematical calculations in his head, calculations that other competent mathematicians had trouble with on paper. It can be said of Euler, as he thinks, he calculates. His works are presently being collected, and I'm a member of the Euler Society, and a lot of research on Euler. All of his mathematical works are found the matrix of nature. And the design acoustics and contributed insights in optics.